Hey there students, it's Miss Adams. In this video, we're going to learn about functions. All right, relations and functions. A relation pairs inputs and outputs. Relations can be expressed as a table, a graph, or a mapping diagram. A function is a relation in which each input is assigned to exactly one output. The vertical line test states that a relation is a function if and only if the vertical line does not pass through more than one point on the graph of the relation. All right. So our first example, understanding relations. Express the relation as a table, a graph, and as a mapping diagram. The relation represents the age of students and the number of words they can write per minute. So age is going to be my x variable along my x-axis, which goes side to side. Words per minute is going to be my y variable, which is along the y-axis. It goes up and down. All right, so my ages are 5, 7, 7, and 8, and words per minute is 7, 21, 23, and 29. I'm pairing them up, the ordered pair that they are with. Then I'm going to graph that. So my ordered pair 5, 7, I'm going to go on the x-axis to 5, the y-axis to 7, so 5 years old and 7 words per minute. Then I'm going to have 7 years old and 21 words per minute, 7 years old and 23 words per minute, 8 years old and 29 words per minute. So that's on a graph. In a mapping diagram, I'm going to put 5, 7, and 8. The 7 gets repeated, so I'm not going to write it twice. The y values, none of them get repeated. And then I'm going to draw little arrows. 5 goes to 7, 7 goes to 21 and 23, and 8 goes to 29. All right, recognizing a function. Determine if the relation is a function. If not, explain why not. So this first one in the mapping diagram, if any of my x terms or my inputs get repeated, it is not a function. So if I look at February, I see it goes to 2 separate values. Therefore, it is not a function, okay, because February has 2 outputs, the 28 and 29. The next one is a table. I'm looking at the inputs, my x's, which are age, and looking to see if there's any input or any repeats. There are none, so this is a function. The next one, I have a graph. I'm going to use the vertical line test, so vertical line is up and down. If I draw a vertical line at 8, I see that it touches more than once. Also at 10, it touches more than once, so this is not a function. Grades 8 and 10 have 2 outputs. Understanding the vertical line test. Use the vertical line test to determine if a relation is a function. So I'm going to draw a vertical line all the way across, like you're going to scan your vertical line all the way across your whole graph, and it should only touch your line or your points or whatever you have drawn on your coordinate plane at one spot. If it touches at more than one spot, it is not a function. For this first one, it only touches at one spot each time, so it is a function. The next one, when I draw a vertical line, it only touches one of my red dots, so this is a function. The next one, if I draw a vertical line, it touches at 2 points, so this is not a function. Domain and range. The domain of a relation is the set of inputs, which are our x values. The range of a relation is a set of outputs. So inputs are your x values, outputs are your y values. Identifying domain and range. So we have a set of ordered pairs. My domain are my x values, and we're going to put them in order. So 1, 4, 7, and 11. We're not going to write them if they repeat. We're not going to repeat them. Range is 2, 4, 6, and 8. Okay, and this would not be a function because some of my x values, 4, and 11 repeat. So because my x values, my domains repeat, it's not a function. The next one, I have a mapping diagram. My domain are the gallons of gas, 10, 15, 16, and 20, and none of those were repeated. My range is 220, 340, and 450, so that one is a function. The next one, I have this continuous curve, which means it's not just ordered pairs or points, it's continuous. I have like an actual line connecting. So my domain is x such that x is between The furthest over on the x-axis that my red curve goes is to -3. And then the furthest over to the y, or the furthest over on the x-axis to the right it goes is to +4. And then I'm going to put the equal to because I do have those filled in circles there. It's including something at the x values of -3 and +4. And I use these braces for my domain and range, the set containing. All right, range is the lowest my graph goes down to is on the y-axis as to -1, and the highest it goes is up to 5. So y, such that y is in between -1 and 5, inclusively, so I'm putting the equal to part on there. And this is a function. It passes that vertical line test. All right, this one, I have this shape here. My domain are the x values. So my shape spans across the x values. The furthest over to the left it goes is to -4. The furthest over to the right it goes is to 1. So my domain is x such that x is between -4 and 1. Or all values of x between -4 and 1. And that would be inclusively, so I'm including those. I'm going to put the equal to. Range are my y values. My y values, the lowest it goes on the y-axis is down to -4. The highest it goes is up to 3. So y is between -4 and 3 inclusively, so I'm putting those equal to's. And this one is not a function. It would not pass the vertical line test. My domain, I'm putting my x values, 2, 7, 8, 11, and 15. My range is my y values, 5, 8, 12, 15, and 19. Again, if I had any repeats, I wouldn't write them twice. This one is a function. The circle, my domain, it's continuous, so it's x such that my x's are between, looks like -3 is the furthest over to the left and +3 is the furthest over to the right, and it is including those values. My range, the lowest it goes, it looks like is -2 and the highest is +4. So remember that your range is your y, so it's between -2 and 4 inclusively. And this is not a function. It would fail the vertical line test. All right, I have a set of ordered pairs. My domain are the x values, 1, 2, 3, 4, 6, and 15. My range are the y values, which they're all 7. None of my x values repeated. It's okay that my y values repeated. This is still a function. All right, this next one, I have this sideways V pattern. My x's are 0, 1, 2, 3, and 4. My range is -3, -2, -1, 0, 1, 2, 3, 4, and 5. Because these are distinct points, you have to write your range as each distinct value. If we connected that all with a line, then we could say the range is between -3 and +5. But because it's individual points, you have to separate them each individual point. This is not a function because my x values are used more than once. And then this mapping diagram, my domain is 0, 1, 3, and 5. My range is -4, -2, 0, and 2. And I can see that 1 is used more than once. And it's an x value, so this is not a function. All right, thanks for watching. See you next time.